Hi, welcome back to Educator.com. Today we're going to talk about graphing calculator basics. First off, if your graphing calculator, your new graphing calculator, comes with a manual, just take a look at the darn thing. Now, I don't mean you have to try reading the whole thing in depth. Just skim it and get a sense for how things work and what your new graphing calculator can do. You don't have to understand everything right from the beginning, but you want to know enough so you can come back later and find something that you're looking for. You're just looking to pick up a sense of how the graphing calculator works. If your calculator did not come with a manual, that's okay. Just play around and experiment. You'll learn how it works by just trying out new things. In English, syntax means how words and symbols are arranged to create meaning. In math, it's the same thing. It's how we arrange numbers and symbols to create meaning. For example, we could write 45 divided by 3 squared times 5 like this, and we would be saying that the number we obtain from dividing 45 by the product of 3 squared and 5. If we wanted a calculator to find the answer for us, which happens to be 1, by the way, we might be tempted to enter the following. So we would use this as our syntax for putting it into our calculator. However, if we did that, we'd actually get 25, which is completely the wrong thing. Why? Because it interprets the above as if we had meant 45 divided by 3 squared times 5. And by the way, if you haven't seen this symbol right here, it's called a caret, and what it means is exponent. So if we write 3 caret and then 7, that means 3 to the 7th when we're used to seeing it. On lots of calculators, though, it can't actually raise the numbers at all, so we wind up using caret to symbolize the next thing is an exponent. However, what it means for next thing is really only the very next thing. So when it sees this as 45 divided by 3 squared, but now we've completed what we're dividing by, and so it moves on to times 5. So the syntax really matters, how we set things up specifically with symbols. This illustrates just how important it is to really think about the syntax we're using with the calculator. Make sure to use parentheses to indicate the proper order of operations. How you want the calculator to do things, you have to tell the calculator with syntax. So if we want to have 45 divided by 3 squared times 5, what we do is we'll say it 45 divided by, and then we'll put quantity 3 squared times 5. That way it knows that it's being divided by the whole thing of 3 squared times 5. Anytime your input might be misinterpreted, use parentheses. It never hurts to have unnecessary extra parentheses. Putting in too many parentheses doesn't actually do anything bad. But oh, how it can hurt if you miss putting them on an important problem. So you're better safe than sorry. If you think it's possible that the calculator won't know what order you want things to happen in, put in parentheses to make it absolutely obvious which one you intend. For example, with this, the 3 caret 2 times 5, 3 exponent 2 times 5, we might be worried that it's going to interpret as 3 exponent 2 times 5, so 3 exponent 10. So we might want to put 3 caret 2 in parentheses as well, and then multiply by 5, that whole thing in parentheses, and we're dividing 45 by that whole thing. Now, as you work more with your calculator, you'll start to get a sense for exactly how the syntax works, and you'd realize, oh, it only interprets the very next thing as being what the exponent is, so I will be safe with just 3 exponent 2 times 5. It'll interpret that as 3 to the 2 times 5. But it takes a little bit of a while to figure out exactly how it works, and once again, you're better safe than sorry, so more parentheses are always a good thing if you're not sure what it's going to have. So along those lines, think about the results your calculator is giving you. You don't want to just blindly assume, because my calculator told me it's got to be right. You want to try to figure out, is this plausible? Is this vaguely reasonable for me to get these numbers out of it right? If we did 45 divided by 3 squared times 5 and it came out as 25, we should go, well, 45 divided by at least 9, 45 divided by something around 10, that's going to be way less than 25, so it sets off an alarm bell. We might not know what the answer is going to be beforehand, and we shouldn't. Why would we be using a calculator if we did? But we have a sense of, a big ballpark range of what should we expect. Should it come out positive? Should it come out negative? Should it be hundreds? Should it be thousands? Should it be a single-digit answer? Should it be small decimals? What's going to happen in a vague sense? That way, if something goes horribly wrong, we'll go, oh, something's weird here, right? So try to figure out what will be a plausible answer before you just punch it in and automatically believe what you see come out of your calculator. And if you wind up seeing something that seems a little bit off, it smells fishy, double check your syntax and make sure you told the calculator what you meant it to do and you didn't accidentally tell it something slightly different from what you wanted it to do. For the most part, you'll almost never need to change the settings on your calculator. Pretty much all the settings on your calculator, you'll be able to just leave them as the factory standard. There are some that you might occasionally want to change, but that's probably sort of an advanced user thing that you won't really need to deal with for many years. The only settings you'll definitely need to care about for the next couple years are what unit angles are measured in and the graph mode. Other than that, you're basically fine leaving all your settings the same. So the calculator has to be told in the settings about angles, though. It has to be told whether the angles that you're working with, the angles you're giving it, and this is for trig functions, are in radians or in degrees. If it's in the wrong one, right, if you mean to do your problem in radians, but you accidentally have it set in degrees, you're going to get completely wrong answers. So it's really important that you know which one it's in and that you have it set in the correct one. It's normally a pretty easy option to find and change whenever you need to. So whenever you switch from radians to degrees, make sure to think about, oh, did I go and change it in the settings? Also, one way to double check which one you're in is to do something like sine of pi over 2 or sine of 90, right? Sine of 90, if you're in degrees, will come out as 1. Sine of 90, if you're in radians, will come out as not 1, and you immediately know if you're in radians or degrees by just putting in this simple number, sine of 90. It will tell you which one you're in without having to check the settings. But it's also normally really easy to check the settings. It's just a single button press, so be careful when you're swapping between radians and degrees. Make sure you're using the right one, because if you aren't, all your answers are going to wind up coming out wrong. The other thing that you have to care about changing is the graphing mode, and that's similarly easy to change. This allows you to switch between function, parametric, and polar graphing modes, and sometimes other graphing modes as well, but those three, function, parametric, and polar, those are the really important ones that you want to know about. Normally, you'll want it in function mode most of the time, and so that's what we'll be talking about first, but we will talk about the other ones later. At the last lesson of this appendix, we'll talk about parametric and polar for a little bit. But normally, most of the time, you'll do all your work in the function graphing mode, and that's what you want to usually leave it in. Occasionally, something will go wrong and your calculator will give you an error message. If that happens, don't panic. You can figure out most error messages simply by reading them and thinking about whatever you just did. Try to get a sense of, okay, what does this kind of mean? And then what did I just do with my calculator that might have caused something to go wrong? Thinking about most of them will probably answer a lot of the questions that you'd have. Now, there might be some cases where you still can't make any sense of what the heck this thing means. And in that case, just do an internet search. Type the product name of your calculator, whatever that is, and then whatever the message says into a quick search, and probably chances are the next thing you'll have is an answer to your question. You'll have it figured out and fixed in no time. So just a quick internet search will solve this for you really fast. Oh, internet, what would we do without you? Oh, right, we'd just look through the error messages in the manual. But we've got the internet usually, right, if you're watching something like this, so why do that if you can just do a quick search? Of course, if you really can't figure out what it is and the internet's no use, try seeing if you can find a manual or email tech support for whoever makes the calculator you're using. Your graphing calculator is, without a doubt, so much more powerful than you currently realize. Virtually all modern graphing calculators can do a wide variety of tasks, more than just calculations and graphing. They're usually capable of working with sequences, series as well, probability, combinatorics, matrices, statistics, finances, and many other things. Normally, you've got a huge array of things that your graphing calculator can do that you aren't even vaguely aware of yet. So basically, if you come across a new topic, chances are your graphing calculator already has some functionality that's connected to this new topic you're learning about. So if you start a new topic and you want to see, oh, it sure would be useful if there was a way a calculator could do this, just do an internet search with the product name you've got and the topic you're interested in. Just search your calculator and whatever the name of the thing you're interested in is, whether it's matrices or probability, and you'll probably be able to find very quickly a guide for doing that specific thing with your calculator, and you'll be able to get an introduction to a new way that you can use your calculator. The easiest way to learn how to use a new graphing calculator is just to play around. I really can't encourage this enough. Be curious, try new things, and see what happens. Exploring on your own will do you a world of good. And don't worry about somehow breaking your calculator either. It's going to be fine. Unless you've decided to explore what happens when you pound against it with a rock. Hint, bad things, you can't do any real harm to a graphing calculator by just playing with it. In the worst case scenario, the absolute worst possible thing that could happen is you might change some setting that causes it to work weirdly, and you can't quite get it to work in a normal way. But if that happens and you can't get it to work in a normal way, just reset the thing and put it back to factory settings, right? You can either search up a quick way to put it back to factory settings, or most of them will have some tiny little pinhole you can press with a toothpick on the back to just put it back into factory settings, and there you are. You're past this, this horrible, weird issue. So you don't really have anything to worry about. Go crazy. Explore, play, learn. Screwing around on your calculator, honestly, is probably the best way to understand how it works later on. By playing around right now, you'll be able to be used to the stuff that you actually have to use in a year or 2 years' time. So it's a great thing to just play with now, and that way you'll see things so that later on when you see new ideas and new terminology, you'll be like, oh, hey, I recognize that. dy over dx. Oh, my calculator can already do stuff with derivatives. Things like that. Pretty cool. All right, in the next lesson, we'll talk about actually putting a graph into a graphing calculator and some other ideas along those lines. We'll see you at Educator.com later. Bye.